This video is a continuation of the data analytics demo for the Chicago crime data using our digit management system. I want to show how easy it is to use our system to find and fix anomalies in data to ensure accurate analytics. As with any analytics function, the cleaner the data is, the more accurate your reports or charts will be. As I showed earlier, we downloaded the Chicago crime data from their open data portal that contains almost 7 million crime reports over the last 19 years. We just double click on the table and we'll show you all the rows in here. We showed how easy it was to drill down and find subsets of this information. We also showed that we could do pivot tables, so we could come up in the primary type, for example, and do a pivot table across years and add those up, and in just a few seconds give you a nice chart of all the crimes reported in the city of Chicago for the last 19 years, how many of each type per year. But this data is only accurate if your data is clean. So I notice right here there's a domestic violence, but there's only one of them in the entire city, and it occurred that very first year. So something has changed here that has a problem. Same with this non-criminal. We see zeros going along here, and then suddenly we start to see a few, and then some more zeros. Trying to figure out, what is doing that, because we see another non-criminal up here and still another one. So looks like some data is not as clean as it should be. So to show this, we can just come up here and show all the values, and sure enough, if we alphabetize it, you'll see 3 different non-criminal categories here. In this case, we have 38 in which they put a couple extra spaces in there, and 170 that show, again, non-criminal, but this time they didn't have the spaces around the dash. So it's up to you to figure out which one is the most accurate, but we can come in and we can change all of them. Let's say we wanted this to be the standard. So we can simply update that value, take out the spaces. We want to update all 38 references. And now, if you go and look at the primary types, for the non-criminal, you should see 208. So we don't see a separate 38 with the spaces and the 170 without spaces. Now there are all 208 rows in which non-criminal is there, and so we can see all of them. Same, we can look at some other types. Come down here to the bottom, there's that domestic violence. What's going on there? It's a primary type with a description. Obviously they changed this to be assault or battery or some other value. So with just one, it's probably not going to throw your analytics off, but you may want to clean that up. So we want to make it easier to find the anomalies, let you figure out how to fix them, and provide tools so that you can fix a lot of things at the same time. Same with the block. So for example, there are 58,413 different blocks within the city. If we sort these by alphabetically, we'll see that, for example, here we have 44 crimes on this 100 place block, East 100 place. But if we go down a little bit, we'll see that there's another 531 on, looks like the same block. So sometime they went in and they decided to put a TH after the 100. And the same with the 101. They put an ST for 101st and an ND after 102nd for both the place and the street. Well, that's a nice little change there, but it can throw your analytics off. If you're wanting to find all the crimes on 100th place, you have to know about both spellings, otherwise you're going to miss some of your data. So we want to make it really easy to come in here, find the data, clean it up, and let you fix the anomalies. Same with perhaps another feature that we can illustrate here is our formatting. So, for example, here we see the date and time in this nice little format here. We've got an ID or a case number, or an IUCR code, whatever that means. Let's look at the formats of this thing. So we can come in here and find out that there's two different formats. There's 4 different digits like 0486, and then there's another set that have 3 digits plus a uppercase alphanumeric or alphabetical character. So there's 290 that have like an A on the end of it or a B. And we want to see them all. We just double click there, and there's the 290. And all these either have an A or there's a P, there's an R. So we can find anomalies. If you have a phone number and you're expecting a certain format, you can come here and in just a couple seconds find all the ones that have an extra dash in them or the parentheses in the wrong spot, or help you find anomalies that way. The cleaner your data is, the better. Also with blocks, we can show you all the values. For example, we see that they have this O'Hare Street, for example, ST. Let's see if there are any that end with a period. You can filter those out, and sure enough, you've got 27 different values, and some are only used a couple of times, but a bunch of them, the rest of them are only used once, in which they put a period at the end of the street. That's non-standard, apparently, because all the others don't have a period at the end of them. And so we can go and fix those. So you can take off the period. I wonder if any of them end in STREET. Whoop. Sure enough, we have another 120 values. This one was used 4 times within the database that spelled it out. And so that'll throw your analytics off if one ends in street, the other ends ST, and the other one ends in ST period. You won't see all the data for that block if you do that. Another one, I see avenue, for example, AVE, but I saw a different one that just had the AV. So let's show the column values, filter on ends with AV. Filter those. Sure enough, we have a set here. Used 327,000 times with just an AV. How many of them have the AVE on the end? Well, in this case, 3.3 million. So it looks like the AVE is the standard, but we have over 327,000 that only had an AV. That will really throw your analytics off. So in this case, we're using crime data, but this could be health information, this could be mortgage applications, this could be all kinds of different kinds of data that need to be cleaned, need to find the anomalies in order to do accurate pivot table type operations. Let's pivot on the block here. This will be a lot more data points. So there's 58,000 different blocks within the city. This takes a couple of seconds. We want to pivot them all by the year and count them up. And in just a few seconds, now we have a table here with 58,000 rows in it and how many crimes were committed on each block. And as we know, again, let's sort that. We see that they put the TH on the end, and it looks like they did it sometime in 2002. They added that TH because without the TH, we have quite a few in 2001 and a few in 2002, but the rest of 2002 completing on have the TH. So that'll help narrow it down when the problem occurred, help you go fix your data and be able to do analytics against that. Thank you very much for your attention.